Hello everybody, today I'm here to teach you right now AMC A preparation. Chapter 1, Perimeter and Area. We'll start from here. Rectangle and parallelogram. So, a perimeter is equals to 2 times L plus W as shown here. And why is it like that? So basically, first we need to know what's a perimeter. So if you have any shape, it might be a rectangle. So for example, we use a rectangle, okay? If this is A, and this is B, and this is C, and this is D. So in this shape, how do you find its perimeter? So it's actually kind of easy. It's A plus B plus C plus D equals to P. Very easy, right? So have a think. Why do you think they did 2 times L plus W? Let's work it out together. So why did they do 2 times L plus W? That's because this is going to be length, right? And this is going to be width, right? If it's like that, the perimeter is not the area, it's a perimeter. Area is over here. So a perimeter is not the volume inside, the volume of the shape. It's the outside layer length of that outside layer. So the length of width and the length of the length, if you add it up together, it will be L plus W, right? And then after that, you need to times it 2. That's because there's another side of it. Get it? Next, we're going to the area. Area is much more easier than perimeter. So how do you find the area? So let's see the rectangle again. So why is it L length times width? That's because you times this and this. So it's basically like a rectangle rule to find the area of a rectangle. So for a rectangle, to find the area of a rectangle is super easy. Just times the length and the width. Done. Imagine, for example question, if this here rectangle, here is 8 and here is 5, try to find the area. Got it? Let's try it out. So the area, it's so easy. This is the width, right? And this is the length. Here, I told you that length times width will equal to area, the volume of the shape. So if it's here, I wrote 8 and 5. So it's basically 8 times 5. That would equal to 40. So if it's 8 centimeters and 5 centimeters, it'll be 40 centimeters squared. Got it? So we're going to the next section. So if we look over here, it shows this can be thought as an area of 2 triangles added together. So this means that, like before the page just now, I made a rectangle of area, right? And a perimeter, right? But when we do the perimeter, there's kind of a reason actually. It's not just like a total math. There's actually a kind of reason. So if you go back here, there's actually a reason why. So if this here, we make it dot until we make that, and then after that we make 2 triangles, right? So first the basics. We need to know the basics. I want to tell you how to find a triangle area. So if there's a triangle like this, then you times this and this. Imagine this is 8 and this is about, 10. Then you 10 times 8. It's basically the same, but you need to divide it by 2. 40 centimeter squared. Like that, okay? That's why if just now it had a 5 and it had an 8, right? Then it will be 40, right? 40 centimeters. But if you separate it, you times it by 5 times 8, right? So 5 times 8 times half. So you'll get half, so it'll be 20. But you times it by 2. So it's basically these two can go away together. That will leave only 5 times 8. That will be equal to 40. That's the reason why. So if we come back to here, it shows us that the same thing I just told you. Length, base, width, height. So you times this, and then you times it by half, but you times it by 2 back. That will make it equal. And then, if you see here, it says height, base. Okay, first I need to tell you a name of this. This shape is called a parallelogram. Get it? Parallelogram. So a parallelogram is kind of like a rectangle squished. So if you see here, we already learned this. We finished this. This time let's do this. This one, oh, they did the same thing. It made 2 isolated triangles. Like this. It might be the same because rectangle square involves in rectangle, so the size might all be the same, like a square squished. But there's another word for like a square squished. It's actually a rhombus. So we can maybe do this like that. These are two same. These two are same. So they can do that, and then you can find their area and stuff. But there's a different way to find a parallelogram area. So if you see here, I drawn a parallelogram, right? They cut in twos, right? But we don't need to do the triangle actually. It's like there's a way. This is important math in how to find a parallelogram's area. So first, we need to know the height as shown in the picture here, okay? Let's say the height is 5 centimeters, okay? And let's say this and this will be equal, right? Maybe 7 centimeters. 7 centimeters. Then it's so easy. You just times 7 centimeters times 5. That's all. Boom, finish. Then it'll be 35 centimeters squared. So the next one is in the parallelogram ABCD, T is an interior point. We have always we'll talk about this later. But first we need to if you might be wondering what is an interior point. That's a good fact actually. So an interior point is if there's a parallelogram, it might not be a parallelogram, but if you put a dot somewhere and then it goes to the angles, like it goes to A, B, C. So imagine there's a it can be rhombus, but let's say it's a parallelogram for now. So let's put it any dot here, maybe middle here. Okay? And then you make the line to each point like this. Okay? Then that will mean like something like if you see here, these two like opposite, like that is not touching each other, like that. Like this. These two. If you add these two, so now it's time to look on this. So it says S, right? So if you go back here, it says A or S. It says A or S is area, right? So that means XS, area. Area of this means triangle. See? This little triangle means is a triangle. S, area of triangle TAB. TAB. So this one. Plus area of triangle TCD. TCD. This one. If you plus that together, equals to the ABCD, you know, the whole triangle, the half of the whole triangle. That means this one, so that means STAB plus STCD equals to, if you see here, S triangle TAB plus S triangle TCD equals to S triangle, guess, TAD plus S triangle TBC. Boom. This is the answer. Like that. So, if you see here, the area is a new topic actually. Area of a rectangle with 4 cut areas. So, a rectangle is divided into 4 rectangles with areas of shown. Look, A, B, D, C, okay? So, the following relationship is true. So, the main thing now is this. You know, opposite sides. Like that's not touching them. Like this, B and C are touching together, but A and C are not. So like this. This and this. So A times C equals to B times D. That's just a topic to know, actually. There's no rule like that. It's just a rule in math. So like example, a large rectangle is partitioned into 4 rectangles like this. 6, this one, this one, this one, and this one, by 2 segments parallel to its sides. The area of 3 of the resulting rectangles are shown like this. 6, 14, and 35. But this one was not shown, right? So what is the area of the 4th rectangle? This one. So we've used our rule, right? This one, A and C, A times C equals to B times D, right? So now this is A, right? And this is C, and this is B, and this is D, right? So we don't know, we need to find what is D, right? So basically, A times C, so 35 times 6. What does it equal to? Yes, 210. I don't know if you can see, actually. Yep. And after that equals to, so 210 equals to 14 times x. So basically is 210 divided by 14. That will give us the answer to x. Easy, right? So let's find it out. 210 divided by 14. 114,705. Boom. X is 15. It is B. Look, there's a solution. B. Method. Let's see how did they do it? 6 times 35 equals to 13 times x. That will equal to x is 15. We did the same method. So if you go back to here, it shows us rectangles of the same height have areas proportional to their bases, like A and B actually. And hence, that's why 6 over 14 equals to A over B equals to something over 35. Let's figure it out now. So 6 over 14, right, equals to A over B, right? That will equal to, so just now it was 6, 14, 35, and this was 15, right? We got that right. That's why 14 over 6 will equal to 35 over, boom, 15. Secondly, we are going to do method 3, official solution. So we can prove that the product of the areas of the diagonal, you see here, this one and this one and this one, opposite rectangles is the same, right? So if segment's length are x and y, and u and v as shown here, then the product of the areas of the lower left here, the lower left, this one, and the upper right, this one, if it there's actually a x here. So let me tell you quickly. If there's a number x, and then if you want to times it by maybe 2 plus 3, if you do it more better and then more like primary 5 ways, not like little guys, or if you want to do higher math, you need to do x, and you can do this right away. You don't need to put the x. Like it already puts the x here. You don't need to write it like this. So back to here. That's why it's xv times u yu. The product of the other area is xu times yv. Since 35 times 6 equals to 14 times something, the area of the fourth rectangle is 35 as shown. Then this will be, what was it? 210, right? Divided, this is divided. You can write it like this or like this. So they wrote it like this time. So divide by 14 will equal to 50. Answer we got. So for the given data here, we can find the answer by factoring the areas, like factoring. Since rectangles of the same height have area proportional to their bases, let's find out. So we use this as 14. So in math, I'm going to tell you this again. Sometimes you do 7 times 2, right? Sometimes you do this, right? You might have seen this. If you didn't, learn. This and this are the times. But actually, in high school math, this is times 2. Sometimes it's a decimal too. So 7 times 2 equals to 14. 7 times 5 equals to 35, right? And this one, times it by 2, then it'll be 6, right? So this will be 5 times 3. That will equal to, it can be 5.3.3, this one and 5. It doesn't matter actually. That will be 15. Boom, like that. So this factor method will not work for everything actually. So for example, if 6 is substitute for 14, it won't work, yeah.